3, 2, 1. It is now standing by. So if I bring my hand, hello and welcome back to Keon's lab, and you are not going to believe how far I've come with this hand dryer. So this hand dryer, which used to require several individual power lines of different voltages, I have now reduced. I know this one looks really bad, but that's why we have this. I have reduced it all down to 2 wires. We have a built-in voltage converter stepping down the voltage for logic level, and then we have our relay voltage as well as our fan voltage, all being controlled. So I went and redesigned the lid here for M3 screws, these ones, and the sockets here aren't quite right. I usually like to put an excess of 0.25 millimeters on all of my dimensions, but it seems like for round things, it seems to be more like 0.45, 0.35, 0.38. The holes on the body here, I extruded them all the way through because it's easier like that than to have it go solid in the center. It's easier to print it like that. Because if you didn't know, when I was designing this used to be just a square like that for the fan. But when I went to slice it, it wanted to put supports like this, just minus all of that and the curves. And I really didn't like that because I told myself, well, if I'm going to put supports anyways, which when I break them away, I'm going to have to sand and it's going to take a long time, I might as well make functional supports. So I just put the supports myself. Gave it enough of a fillet or fillet, I don't know how you pronounce it, so that when it's printing, it doesn't have an overhang that would make it necessary to need a support, as well as adding slots on the top, sides, and bottom for air. I didn't put any here so that when it's being screwed into, it has some support there, but I did put one on the top, as well as on the sides. But I purposefully didn't put it on both sides because I wanted to have a little bit of... Now, I'm not sure if this is how it works. I haven't really read up on this subject the most, but at least the way it seems to me is that if I restrict the airflow a little bit, it might work with a little bit more pressure. I'm going to have to test that. That might be a future video. But I bought this fan and it was so powerful. It's 1.68 amps, 12 volts. So it's a 20 watt fan. And it was really powerful. And I said, you know what? This would make a really good hand dryer. Because when I'm working with stuff, especially like humidity sensors that are very sensitive to the moisture that may be on fingers when you're soldering them and stuff, I always like to put my hands in front of a fan after washing them. Because I always wash my hands to get them super oil free so I can handle stuff super good. But I was really getting annoyed of having to plug in and out the fan with like my sealed lead acid battery every time I wash my hands. So I made this. So let me plug it in. And it's going to turn on when I first plug it in. Oops. Here is where I did a lot of the work. So I'm editing the video that's going to be the long form of how I made this into like what it is now from what it was from my part 1 of my video, which is, it was just a dumb dryer. So you would put your hand in front of it and it would work the same, but you had to give the voltages separately. Or actually, did I even no, I didn't even show that in my first video. So my first video only showed the dryer with the fan connected to power. That's it. So you guys have not even seen how far I've come with this. So I tried out several different LiDAR modules and found that the VL6180X by STelectronics is the optimal one for this purpose because it has, I'm going to put somewhere here, the maximum distance in centimeters or millimeters that it can detect. It's optimal for low light conditions, and it is ultra precise for ranges under, I believe it was 10 centimeters. If I'm wrong, I'm going to put that here also. I added silicone on the sides because I hadn't screwed the screws in all the way, because I used the wrong screws because I didn't have the right ones, and I sort of had a gap, so I had to fill it in with silicone. And I don't want to, actually it's fine now. So I have the relay module stuffed into here very poorly. This is like a very, very, very bad draft version of this, but I have the Arduino stuffed in. Everything is electronically insulated using Wago connectors. Let's see. And I also have a step down module that is stepping the power down from 12 volts, because you can feed this anything. You can feed this anywhere from 12 volts to, well, realistically, you can feed this anywhere from 8 volts to 16 volts, but I like to keep it at around 13 volts, 12 to 13 volts. So feeding it 12 to 13 volts, I have it written on the tag here, 12 to 16 volts, but 12 to 13 volts will be going to the relay module, which is standing by to feed that 12 to 13 volts into the fan, while a step-up module is continuously stepping that power down to power the Arduino Nano in here, which is running the code I wrote to detect movement. And it's not just a dumb code, it's kind of running a very basic algorithm. It's checking for continued presence, not just maintained presence. Now, this doesn't really work as well in reality as I thought it would, so I'm probably going to be changing that in the future, but because it's kind of a pain to have to take everything out and plug it in to reprogram it, I just want to show it working here. And I'm also going to be reprinting a lid that has a notch on the top for the LiDAR sensor, and I'm probably going to put a notch here so I can recess it in and then screw it in. I don't know, but I'm probably going to have to figure that out. I'm probably going to have to figure that out separately, but I have 12 volts standing by that I'm going to plug into the back of this, and it's going to turn on for the first time that it's plugged in, but then it's going to stand by. And I've actually used this hand dryer by putting it on a bench outside of a washroom in the house to see if when people walk past, does it trigger itself, and does it trigger itself randomly overnight? And it does not. It is perfect. Like, it is everything you would want from a hand dryer, everything you would expect from a hand dryer that looks like this, just like the ones that you see in like commercial buildings. And for those who would like to see the drawing, I printed it out from Autodesk Inventor. This is 100% my design. So you can see everything is here. All the perfect flush connections are designed by me. And what I mean by that is when you put the fan, 60-38 fan, so 60 by 60 millimeters by 38 millimeters deep, and put the fan in, and then you put the lid, or, oh, I did not print the spacer. So if I hold, so you can see there's a little gap here, and that's because if I were to bring it any higher here, the overhang and the supports really wouldn't make sense. It would get in the way of any wires and stuff. So I printed a separate spacer that just goes around here and has screw holes in it, but I completely forgot to print that when I was printing this out. But this is just a quick update video to show you the working module anyways, or the working hand dryer anyways. So this isn't the biggest deal. I'm just going to skip to showing the hand dryer working. Okay, so the power supply is off, and when I turn the switch on, we are going to have 12.5 volts going in. In 3, 2, 1. So it's going to turn on. and it is now standing by. So now, if I can focus on it, it is now standing by. So if I bring my hand, let me go and get a piece of paper towel to show you the movement of air. Okay, so I've got this piece of paper towel. This might be a little bit too big. Let me make little ribbons out of it. Here. This is not very professional, but anyways. So. You might have just noticed, oh, it's gonna go off. So because I set it to go off within this range, it kept going off, so I had to unplug it. But you may have noticed it actually tried sucking the paper towel in when I brought it too low. And that was because my plan with the limited side slots for the air intake seems to be working. Something which I actually demonstrated with the paper in my first video. And yes, I know Adam Savage says not to refer to old videos, but what am I going to do with that? I'm going to have to make a new video that I'm working on right now, which is going to demonstrate that, because I've been working on several different projects at the same time. My previous video on the FLIR camera took me almost 40 hours to make, because I'm learning at the same time as I'm editing and recording, along with all the technical difficulties. But now it's time to quickly show the assembly of this, because I only have 10% battery left on my phone and it's about to die. So I'm going to show you how beautifully this goes in. So you can see, well, you can't see it like that. Oh my god. So this is the back plate, and this was actually one CAD model that I put into a program called Slicer, SLIC3R, that's how it's spelled. And I just cut it so that I could 3D print it easier, because I couldn't 3D print it like this because of the overhangs here and here, so I had to 3D print this flat and then print this standing up, because of course it had the supports that I put in, the functional supports. But to assemble it, it's quite easy. Put it here, and I was going to put T-slots like I mentioned in the first video, but it's a little bit too thin for T-slots to work effectively with a 0.4mm nozzle. But I will be getting a resin printer in like a couple of months, maybe less, but that's going to allow me to really have more accuracy when I 3D print. So assembly is as easy as taking the back plate and then putting the front plate on, preferably maybe putting some silicone and then putting it on, and then aligning everything. And all the screws are M3. They're the same length. I don't remember what length it is. It's an M3 by 20. Now with the sellers that I buy from, like the Chinese vendors, sometimes they specify the length from here to here. Sometimes they specify it from here to here. They don't really go by the official thing. Sometimes they specify it from the midpoint of here to here. So I'm not really sure which one it was, but you can see the dimensions here. And I'm going to be making the STL files available once I have everything set up and ready to go. And I'm actually considering maybe making like a do-it-yourself kit. So I don't know if that's something people would be interested in, but let me know in the comments if you would be. And by the way, the hole here is for the USB cable for programming, back when I was debugging it. So putting the screws in. And of course, the do-it-yourself kit version most likely would not be using 3D printed parts like this. It would be using resin 3D printed parts. So it would be very, very, very similar to injection molded plastic parts, because it would be fully solid plastic. It could even be transparent. So I'm not going to put all of the screws in again because I already put them in once and I had to take them out again to record this. And there aren't threads built into this, so the carved threads that the screws made the first time, I don't really want to ruin them by putting it in and out so many times. So I'm going to have to end the video here, but I'm going to do another demonstration right before I do of this hand dryer working because I know it's pretty cool. I'm honestly surprised by my own work. I never thought I could design something like this. And the hand dryer is actually taking 4 measurements every 25 milliseconds, I believe, or 15 milliseconds, I don't remember. I need to go back in the code, but I'll put it here. But it is checking for that presence of the hand, and if it's there, then it's going to trigger it. Okay, so I just remembered it wasn't for hygienic reasons. It was actually checking for if an object is obstructing. So it's checking for presence while it is turning the fan on, because it's not just using a simple delay. It's using it's not really that complicated, but it's using a counter system so that it can be constantly monitoring the presence of whatever object is moving in front of the LiDAR sensor while the fan is on, so it can be aware if something is just sitting here and not moving, or if it's actually a human hand trying to drive our hands. And I made this because I thought, well, if it's a commercial device, that's like a selling point, right? You want to be able to say, hey, people can't just put like a chair in front of it and waste all your power all day long, especially if it has a heater built into it, which is something I'm considering doing. But as you can see, it is plugged in, but because this object here that I put is not moving, it's not going to turn on. And that's regardless of the distance, as long as it's within the trigger distance. But as long as I move it more than 5 millimeters plus or minus from where it was standing, it turns on. But again, I didn't move it, so it doesn't turn on. But if I move it, and then simulating the hand movements of someone drying their hand. It keeps turning on. It doesn't wait. It keeps turning on. And it doesn't turn on excessively. As you saw when I took my hands away, it didn't turn on again. So that's a lot of polish that I had to add to this program, which took me a few months to do. So that's the end of this little update on the hand dryer, because I still haven't got everything done. But if you like this type of video, please remember to like and subscribe to the video, and thank you for watching, and I'll see you in the next video.